What if ringing in your ears isn't only about your ears? What if tinnitus can also be influenced by what's happening in your brain, your nerves, your neck, and your jaw, and even the systems that help move fluid and waste around your brain? Because here's something fascinating. Scientists are discovering that tinnitus may involve far more of the body than we once realized. And that could help explain why tinnitus can be so difficult to resolve. Welcome to the Lymph-Brain Revolution Podcast. I'm John Ossipinsky. Most people know me as LymphMan. Recently, I've been doing a lot of research on tinnitus, and something happened on my Instagram page that made me want to investigate this even further. I asked my followers to try a simple experiment. I had them place two fingers alongside their nose and gently press inward and downward on the face and cranium. Then I asked them to pay attention to what they heard. I received a lot of responses. Many people told me that when they applied the pressure, they suddenly heard more white noise, ringing, or buzzing. Interestingly, some people who already had severe tinnitus told me they didn't notice much of a difference. Now, this wasn't a scientific study. There was no control group, no standardized pressure, and we're certainly not going to use these responses as proof of what causes tinnitus. But as someone who has spent more than 30 years working with the lymphatic system, the tissues of the head and neck, and people with chronic health problems, the responses caught my attention. They raised a fascinating question. Why should pressing on your face change what you hear inside your head at all? So I started digging deeper into the research, and I discovered that scientists already know something remarkable. Sensory information coming from the face, jaw, and upper neck can interact with the areas of the brain involved in processing sound. That led me further. I found research involving inflammation and tinnitus. I found oxidative stress, mitochondrial dysfunction, cellular aging, and changes in circulation within the inner ear. Then we get into anxiety, stress, and sleep, and how all three can influence how intensely the brain responds to tinnitus. And perhaps most interesting for this podcast, emerging research is now finding associations between chronic tinnitus and measurements related to the brain's glymphatic fluid clearance system. And we'll discuss that more later. Now, none of this means that restricted lymph flow causes tinnitus. We don't have evidence to say that. But it does tell us that tinnitus is much more complicated than simply having a problem with your ears. And that's what I want to investigate with you today. What is happening throughout the ear, the brain, the nerves, the tissues, and fluid clearance systems that allows a sound that isn't there to become so real and sometimes so difficult for the brain to stop hearing? By the end of today's episode, I think you'll look at tinnitus very differently. Before we begin, tinnitus can have many different causes, and some forms require medical evaluation. This episode is educational and isn't intended to diagnose your tinnitus or replace evaluation by an audiologist, ENT physician, or another qualified healthcare professional. Later in this episode, I'll explain several warning signs that should not be ignored. Today, you'll learn why tinnitus can begin with changes in the ear but become established through changes in the brain. We'll explore why touching your face, moving your jaw, or changing your neck position can alter tinnitus in some people. We'll also look at inflammation, cellular aging, stress, sleep, glymphatic function, and what all of this could mean for supporting the health of the auditory system. And most importantly, we'll talk about what you can realistically do with this information. Let's begin with the obvious question. What exactly is tinnitus? Tinnitus is the perception of sound when there isn't an external source creating that sound. Some people hear ringing, others hear buzzing, humming, hissing, roaring, clicking, static, or white noise. Tinnitus is incredibly common. About 25 million American adults have experienced tinnitus lasting at least 5 minutes in the past year. Tinnitus can develop for many different reasons. Hearing loss and exposure to damaging noise are among the most common, but tinnitus can also be associated with aging, ear injuries or infections, certain medications, Meniere's disease, jaw and neck problems, head injuries, and other conditions affecting the auditory or the nervous system. And sometimes there isn't one obvious cause. Although we commonly say, my ears are ringing, persistent tinnitus isn't necessarily being generated only inside the ear. To understand why, we first need to understand what happens inside the cochlea, the small spiral shaped organ of the inner ear. The cochlea's main job is remarkable. It converts the mechanical vibrations of sound into electrical signals that your brain can understand. Think of it as a biological translator. Sound begins as a physical wave traveling through the outside world, but your brain can't interpret those vibrations directly. The cochlea changes those mechanical vibrations into the electrical language of the nervous system. And the cochlea is filled with fluid. And its outer chambers contain a fluid called perilymph, while the central cochlear duct contains a different fluid called endolymph. These fluids have very different concentrations of electrically charged minerals or ions, and maintaining that precise balance is essential for normal hearing. As sound vibrations enter the cochlea, they create waves through these fluid-filled chambers. Those movements ultimately bend tiny structures on specialized sensory hair cells. When those hair cells bend, they convert that mechanical movement into electrical activity. That information travels through the auditory nerve, into the brainstem, and eventually into higher areas of the brain, where your brain interprets those electrical signals as the sounds you hear. So think of your ear as the microphone, the cochlea as the translator, and your brain as a sound processing system. And here's why understanding that matters for tinnitus. Hearing depends on an incredibly precise fluid, electrical, cellular, and neurological environment. It's all about the environment. If something damages the hair cells, alters their connections with auditory nerves, or reduces the quality of information leaving the cochlea, the brain suddenly has a different signal to work with. And surprisingly, the brain doesn't always respond to reduced auditory input by becoming quieter. Sometimes it does the opposite. Researchers describe one mechanism as central gain. Imagine turning down the signal coming into a stereo amplifier. If you're struggling to hear the music, you might turn up the amplifier. The brain can respond to reduced auditory input in a somewhat similar way. Neural circuits can become more sensitive as the brain tries to compensate for missing information. But if you turn an amplifier high enough, you don't only amplify the music, you also amplify the background noise. And that is one possible way phantom sound can emerge. And over time, tinnitus can involve changes in the auditory brainstem and brain itself. This helps explain why two people can have similar hearing loss while one develops severe tinnitus and the other does not. And here's something interesting. Some people with tinnitus appear to have relatively normal hearing on an ordinary hearing test. Researchers continue to investigate whether some of these people have subtler damage involving connections between cochlear hair cells and auditory nerve fibers, sometimes discussed as cochlear synaptopathy or sit-and hear loss. That doesn't explain every case of tinnitus, and the science is still developing. But it enforces an important point. A standard hearing test doesn't necessarily tell us everything about how information is traveling from the inner ear into the nervous system. And once we understand that tinnitus involves both the signal coming from the ear and the way the brain processes that signal, my Instagram experiment becomes much more interesting. Because the auditory system does not function separately from the rest of your sensory nervous system. Remember what I asked my Instagram followers to do? They place their fingers along their noses, apply gentle pressure in and down, and notice whether the white noise, ringing, or buzzing they perceived changed. Many told me it became more noticeable. There's an established area of tinnitus research that helps us understand why something like this is possible. It's called somatosensory tinnitus. It's a type of tinnitus in which sensory information coming from the body, particularly the jaw, the neck, the head, and face, can influence the tinnitus someone hears. Moving the jaw or neck, tightening certain muscles, changing posture, touching the face, or applying pressure can sometimes change the loudness or pitch of the sound. Your somatosensory system carries information about touch, pressure, muscle tension, movement, and the position of different parts of your body. Researchers have found that some people can change their tinnitus through these types of movements or physical stimulation. I'm actually one of those people. I can change what I hear by tightening the muscles in my neck and jaw or applying pressure to certain areas of my face and head. Let me know if you hear more white noise when you tighten your neck and jaw muscles. So why would something happening in your jaw, neck, or face change a sound you're hearing? One important player in all of this is the trigeminal nerve. The trigeminal nerve carries sensory information from much of your face, forehead, nose, jaw, and other tissues of the head. Sensory information also travels from the upper cervical nerves in your neck. Think about that for a moment. You can move your jaw, tighten your neck, or press on your face, and for some people, the sound they hear inside their head changes. And here's the fascinating part. Those sensory pathways can interact with neurons in and around the cochlear nucleus, one of the first brainstem regions involved in processing auditory information. The brain doesn't keep all of this information in completely separate compartments. Sound enters through one pathway, touch and pressure enter through others. Your neck and jaw are continually sending sensory information as well, and those pathways can interact. So if clenching your jaw changes your tinnitus, your jaw obviously didn't suddenly damage your hearing. You changed the sensory information reaching your nervous system, and that can influence the way auditory information is being processed. That gives us a scientifically grounded way of interpreting what many of my Instagram followers experienced. Their responses don't prove that the tissue surrounding their brains were tight, and they don't prove that their lymphatic systems were congested. But they demonstrate an important principle. Mechanical sensory input from outside the ear can change what some people hear. Now let's take that a little further. There is a recognized type of tinnitus associated with problems involving the cervical spine and neck called cervicogenic somatic tinnitus. Some people with this form of tinnitus also have neck pain, restricted movement, muscle tension, previous neck injuries, or other cervical problems. The jaw matters too. Temporomandibular disorders, commonly called TMJ problems, can occur along with tinnitus, and moving or clenching the jaw can sometimes change the sound. This part of the research really caught my attention because I've observed something similar in my own work. Over the past 30 years, I've had clients come to me for completely different health concerns who also mentioned that they had tinnitus. Tinnitus wasn't necessarily why they came to see me. Often, after a few sessions focused on relaxing the body and improving movement and lymph flow through the shoulders, neck, and head, they would tell me their tinnitus had become noticeably quieter or had gone away. Now, that's my clinical observation. It doesn't prove that improving lymphatic flow reduced their tinnitus because several things were changing at the same time. We were relaxing muscular tension, creating more movement through the neck and shoulders, supporting circulation and lymph flow, and helping the body move into a more relaxed state. But those experiences stayed with me because they raised the same question we're exploring today. Why would changing what's happening in the neck, shoulders, and tissues around the head and ear change what someone hears? What's fascinating is that researchers have actually tested part of this question. In one control study, people with severe tinnitus and neck complaints received several weeks of cervical physical therapy. Tinnitus complaints improved in a meaningful number of participants. More recently, researchers studying people with somatic tinnitus found that manual therapy combined with some home exercises produced better outcomes than exercises alone on several measures. It's really what you can do at home every day, a few times a day. That doesn't mean physical therapy treats every form of tinnitus, and it certainly doesn't prove that the lymphatic system was responsible for the changes I've observed in my clients. But it tells us something much more useful. In appropriately selected people, changing the function of the neck and musculoskeletal system can change their experience of tinnitus. And now we have to ask why. Muscles and connective tissues aren't simply those ropes holding your body together. They contain sensory receptors that are constantly sending information to your nervous system. How much tension is there? Where is my head positioned? Is this joint moving normally? How much pressure is being placed on this tissue? When muscles or surrounding tissues remain chronically tense, irritated, or restricted, the sensory information reaching the nervous system can change. And if those sensory signals interact with auditory pathways, we begin to understand why problems involving the neck or jaw could influence tinnitus in some people. This raises another interesting question. What about the tissue surrounding the brain? The meninges are connective tissue membranes surrounding your brain and spinal cord. They contain blood vessels, immune cells, sensory nerves, and lymphatic vessels. The outer layer, called the dura, receives sensory innervation connected with the trigeminal system and upper cervical nerves. These tissues can respond to mechanical and inflammatory stimulation. Now, I want to be very precise here. We do not have research proving that ordinary tightness of the meninges physically pulls on the ears and causes tinnitus. I don't want to turn an interesting hypothesis into a scientific fact. It's not there yet. But based on what we know about the trigeminal system, cervical nerves, somatosensory tinnitus, and the sensory innervation of these tissues, I think we can legitimately ask, could altered mechanical input or tension from tissues of the head and neck influence sensory nerves that communicate with auditory pathways? We don't have the complete answer. But now the observation we started with, why pressing on the face can change what some people hear, doesn't seem quite as mysterious. And there's another factor that can change how sensitive and reactive these neural pathways become: inflammation. And that's where we're going next. Now that we understand how sensory input can influence tinnitus, there's another factor that can change how reactive auditory pathways become: inflammation. One important part of that story involves microglia. Microglia are specialized immune cells that live in your brain and spinal cord. You can think of them as part of the brain's built-in surveillance and cleanup systems. They're constantly monitoring the environment around your neurons, looking for signs of injury, infection, or cellular damage. They also help clear away damaged cells, cellular debris, and other material that doesn't belong there. When something goes wrong, microglia can quickly become activated. They change their behavior and release chemical signals that help coordinate the brain's immune response. That's normally protective. If tissue has been injured, you want your immune cells responding to that injury and helping with cleanup and repair. But problems can develop when microglia remain activated for too long. Instead of helping resolve the problem, prolonged microglial activation can contribute to ongoing neuroinflammation. The inflammatory chemicals that they release, cytokines, can change how nearby neurons communicate and how excitable those neurons become. And that's where this becomes important for tinnitus. Animal research has shown that exposure to damaging levels of external noise, the kind of loud noise that can cause hearing loss, can increase inflammatory signaling and activate microglia in auditory regions of the brain. So we're talking about exposure to things like very loud machinery, amplified music, explosions, or other damaging external sounds. Not the white noise or ringing someone hears from tinnitus itself. One particularly interesting study examined an inflammatory molecule called tumor necrosis factor alpha, or TNF alpha, which is a pro-inflammatory cytokine. Increased neuroinflammatory activity and altered the balance between excitatory and inhibitory signaling in the auditory system. Think of that balance like the accelerator and brake inside a neural circuit. If inflammatory signaling pushes harder on the accelerator while weakening the brake, auditory neurons can become more excitable. That could make abnormal neural activity and potentially tinnitus more likely to persist. Here's what's fascinating. When the researchers reduced that inflammatory signaling, the tinnitus like behavior in the animals was also reduced. Animal research doesn't prove that reducing inflammation will improve tinnitus in humans, but it tells us that the immune environment around auditory neurons deserves our attention. Tinnitus may involve more than the quality of the auditory signal. The conditions surrounding the neurons processing that signal can matter too. And this is where the lymphatic system begins to enter our story. Remember, the lymphatic system is a tiny network of vessels and nodes. It's everywhere in our body, especially in our neck. This is where all the lymph has to flow, right behind your clavicles. And when this system can't flow, then we're going to get a backup of waste. And that waste can interfere with how the organs and tissues function. The body doesn't only need to activate an immune response. It also has to resolve that response and deal with the excess fluid, protein, cellular debris, and damaged material. The brain has specialized fluid clearance pathways, and the membrane surrounding it contain lymphatic vessels. We'll come back to those later because researchers are now investigating whether those pathways could also be relevant to tinnitus. Microglia participate in that surveillance and clean up within the brain and spinal cord. Fluid clearance pathways help move material through and around the tissues of the brain, while meningeal lymphatic vessels provide another connection between the brain surroundings and the body's lymphatic system. We don't yet know whether impaired glymphatic or lymphatic clearance contributes directly to tinnitus. But if we're trying to understand the conditions surrounding the neurons involved in hearing, then immune regulation, fluid movement, and waste clearance deserve to be part of the conversation. And now that raises another question. What was happening inside the ear that changed the auditory signal in the first place? To understand that, we have to go back into the cochlea. When the cochlea is converting sound into electrical information, it requires an enormous amount of precision and cellular energy. To do that accurately, the sensory structures inside the cochlea depend upon a remarkably precise balance of oxygen, nutrients, electrical gradients, fluid composition, circulation, and cellular energy. Remember that the cochlea contains two specialized fluids, perilymph and endolymph, with very different concentrations of electrically charged minerals. Healthy circulation helps maintain the precise conditions these fluids in the cells of the cochlea need for normal hearing. The cochlea has a specialized vascular structure called the blood labyrinth barrier. You may have heard of the blood-brain barrier, which helps regulate what moves between your bloodstream and your brain tissues. The inner ear has its own specialized barrier that helps regulate what can move from the blood into these very sensitive cochlear tissues. And there's a reason the cochlea needs that protection. Hearing depends on precision. The hair cells, nerves, fluids, and electrical conditions inside the cochlea all have to work together. One threat to that delicate balance is oxidative stress. Your cells naturally generate reactive molecules as part of normal metabolism. Under normal circumstances, antioxidant systems help keep those molecules under control. But exposure to damaging noise, aging, infection, inflammation, and certain medications and metabolic problems can increase the oxidative stress beyond what cells can comfortably manage. When that happens, cells can become damaged and normal tissue function can begin to suffer. Mitochondria are especially important here. They're responsible for producing much of the usable energy your cells need. Remember, the mitochondria are the powerhouse of the cell. And because the cells of the cochlea have high energy demands, mitochondrial health is critical to hearing. When oxidative stress damages mitochondria, cells can become less efficient at producing energy while potentially generating even more damaging reactive molecules. It's like an engine beginning to run poorly while producing more exhaust at the same time. Over time, hair cells can become damaged. Connections between those hair cells and auditory nerves can deteriorate. Small blood vessels and supporting tissues can be affected, and the quality of the auditory information leaving the cochlea can decline. Now go back to what we learned in segment 1. What can the brain do when auditory information becomes weaker or distorted? It can turn up the gain. So now we can see another possible chain: cochlear stress, poorer auditory information, brain compensation, greater neural sensitivity, and tinnitus. Now let's put that into perspective. The quality of hearing depends on an entire living ecosystem. Blood vessels have to deliver oxygen and nutrients. Mitochondria have to produce energy. The cochlear fluids have to remain carefully regulated. Immune responses need to activate when they're needed and then resolve. Nerves have to send accurate information. And damaged cellular material has to be repaired, recycled, or removed. That's why tinnitus doesn't necessarily begin with one thing going wrong. Different problems can ultimately disturb the quality of information traveling from the ear toward the brain. And as we get older, another factor becomes increasingly important. What happens when cells become damaged or stressed, but instead of dying or returning to normal, they remain in the tissue and begin affecting the cells around them? That's where senescent cells enter the tinnitus story. You've probably heard me talk about senescent cells before. They're often called zombie cells, although they aren't actually dead. They're damaged or stressed cells that have stopped dividing normally but can remain biologically active. Some senescent cells release inflammatory chemicals and other signals that can affect surrounding tissues. Researchers call this the senescence-associated secretory phenotype, or SASP. Scientists are increasingly studying cellular senescence in aging tissues throughout the body. The inner ear is one of them. Research into age-related hearing loss has identified cellular senescence, oxidative stress, mitochondrial dysfunction, and reduced cellular housekeeping as possible contributors to deterioration within the cochlea. If it can't clean itself, it's going to have problems. And here's an important distinction. We do not have good evidence that says senescent cells directly cause tinnitus. That's too big a leap. The connection is more likely indirect. As cellular damage accumulates with age, senescent cells can contribute to inflammatory signaling and poorer tissue function. Hair cells, supporting cells, nerve connections, and vascular structures can become less healthy. The auditory information reaching the brain becomes less reliable. And once again, the brain may compensate by increasing sensitivity. So the takeaway isn't that a zombie cell creates ringing in your ear. It's that cellular aging can contribute to deterioration of the hearing system, and deterioration of that system can make tinnitus more likely. This is an important shift in thinking. Protecting hearing isn't only about avoiding loud noise. It's also about supporting the health of the tissues that make hearing possible. And now we come to another system that can dramatically change how tinnitus is experienced: the stress response. Any of you have stress? Before we go further, if something you're hearing today is making you think differently about your own health, about tinnitus, that's exactly why I created the Lymph-Brain Revolution Podcast. Sometimes we spend years treating individual symptoms without looking at the systems supporting the tissues where those symptoms are occurring. If you'd like help understanding your own lymphatic health, I offer lymphatic health coaching along with online courses designed to help you better understand and maintain your lymphatic system. You can learn more at healthylymphsystem.com. Now let's go back to tinnitus, because what happens when the brain becomes worried about the sound can be just as important as the sound itself. Imagine hearing a ringing sound for the first time. Your brain immediately wants an explanation. What is that? Where is it coming from? Is something wrong? You listen for it. The more concerned you become, the more attention you give it. Researchers found strong relationships between tinnitus, anxiety, depression, stress, and insomnia. A recent meta-analysis looking across multiple studies found that tinnitus was associated with higher odds of anxiety, depression, stress, and particularly sleep problems. But that doesn't mean tinnitus causes every case of anxiety or depression. And it doesn't mean anxiety causes tinnitus. The relationship can reinforce itself in both directions. Tinnitus can create stress. Stress increases vigilance. Vigilance makes your brain pay closer attention to the tinnitus. The sound becomes harder to ignore. That creates additional stress. Your sympathetic nervous system becomes more active. It's on alert. Muscles can tighten. The jaw clenches. The shoulders rise. The neck becomes guarded. Now think back to what we already learned. Those same jaw and neck tissues can send sensory information into the tissues capable of influencing auditory processing. So a feedback loop can develop. Tinnitus, stress, muscle tension, altered sensory input, greater attention to the tinnitus, more stress. That does not mean tinnitus is imaginary. The perception is real. It means the way your brain evaluates and reacts to that perception can influence how disruptive it becomes. That's why one of the most consistently supported treatments for bothersome tinnitus is cognitive behavioral therapy, or CBT. Cognitive behavioral therapy is a type of talk therapy that helps change how your brain reacts to the ringing or buzzing. CBT doesn't necessarily stop the sound itself. Instead, it helps train your brains to stop treating the tinnitus as a threat that constantly requires your attention. Remember the cycle we talked about earlier. You hear the ringing, you become concerned about it, you start listening for it, and the more attention you give it, the more intrusive it can become. CBT helps interrupt that cycle by reducing the fear, stress, and negative thoughts associated with the sound. The tinnitus can still be there, but as the brain stops treating it as a threat, it can become easier to ignore and much less disruptive to your life. A recent umbrella review examining dozens of systematic reviews found that CBT, hearing aids, tinnitus retraining approaches, and sound or music therapies were among the treatments with the most consistent evidence of benefit. And sound or music therapies is just putting sound into your ears. It can be a beach sound, it could be music, it can be white noise. Think about what that tells us. You don't necessarily have to eliminate every abnormal auditory signal to dramatically change someone's experience of tinnitus. Sometimes you just change the brain's reaction to the signal. And this becomes particularly important at night. The house gets quiet, the television goes off, the conversations stop, there are fewer external sounds competing for your attention. Suddenly, the tinnitus can seem much louder. The auditory signal itself may not have changed very much. The contrast changed. During the day, your brain is processing conversations, traffic, music, work, movement, and thousands of other sensory signals. At night, those competing signals disappear. Tinnitus moves towards the front of your attention. Then you start worrying about whether you'll sleep. That increases arousal. Now you're lying in bed listening even more carefully for the sound you desperately don't want to hear. Tinnitus interferes with sleep. Poor sleep makes tinnitus more difficult to cope with. And recently, this connection became even more interesting. Scientists have started investigating tinnitus and the brain's fluid clearance system. Now, this is interesting. Researchers have begun using MRI measurements to investigate whether people with chronic tinnitus show differences associated with glymphatic function. The glymphatic system moves fluid through spaces associated with blood vessels and brain tissue. This fluid movement appears to help distribute substances and clear metabolic waste from the spaces around brain cells. Sleep is particularly important to this process. Recent studies have reported altered glymphatic-related MRI results in groups of people with chronic tinnitus, including relationships with sleep disturbance. That does not prove glymphatic clearance causes tinnitus. Tinnitus could disrupt sleep. Poor sleep could affect lymphatic fluid movement and waste clearance processes in the brain. Changes in brain health could contribute to both. We don't yet know which direction the relationship runs. But the fact that these researchers are finding these associations is important because it opens up another way of thinking about tinnitus. And this is where the lymphatic system enters the story. For many years, the brain was taught as being largely separate from the body's lymphatic system. That view has changed. In 2015, researchers described functional lymphatic vessels within the meninges, the membrane surrounding the brain. These vessels transport fluid and immune cells and communicate with lymphatic pathways outside the skull, including cervical lymph nodes and vessels. The brain is not isolated. It participates in fluid and immune pathways that ultimately connect with lymphatic structures in the neck. Think about how much our understanding has changed. Just over 10 years ago, most people didn't even know there were lymphatic vessels in the membrane surrounding the brain. Today, researchers are investigating whether changes in brain fluid clearance pathways are associated with chronic tinnitus. Now, let's be very clear about what this does and does not mean. Scientists have not proven that blocked lymphatics cause tinnitus. They have not proven that manual lymphatic drainage treats tinnitus. And they have not shown that performing the shoulder shuffle changes lymphatic clearance inside the brain. Those claims would go beyond the research. But here's what we can say. The brain depends upon healthy fluid movement. Sleep influences that process because the glymphatic system cleans 90% at night. The meninges around the brain contain lymphatic vessels. Brain-associated fluid and immune pathways connect with the lymphatic pathways outside the skull. And researchers are now finding associations between tinnitus and measurements related to lymphatic function. That gives us a legitimate new question. Could the ability to maintain healthy fluid movement and waste clearance around the brain influence the conditions in which tinnitus-related neural activity occurs? That's not a conclusion. It's a question for future research. But it's a much more scientifically grounded question today than it would have been even 10 years ago. And this is one reason the research caught my attention. Over more than 30 years of working with the lymphatic system, I've seen how relaxing the shoulders, neck, and tissues around the head while improving movement and lymph flow through these tissues can sometimes change the symptoms people experience. Those observations do not prove that lymphatic work treats tinnitus. But when science begins connecting the brain, meninges, cervical lymphatic pathways, sleep, immune activity, and fluid movement, I think we should pay attention. These systems are not separate. I've experienced tinnitus myself, twice. I developed after having COVID. For me, it didn't begin while I was actually sick. For me, it didn't begin while I was acutely sick. It appeared roughly a month later after I had healed. I remember the white noise and ringing, and I remember how difficult it was not to pay attention to it. Both times I worked consistently on relaxing the tissues around my neck, shoulders, and head and supporting movement, circulation, and lymph flow. Over a period of weeks, the tinnitus eventually resolved. I can't tell you that what I was doing caused it to resolve. That's my personal experience, not scientific evidence. But tinnitus has been reported after COVID infection, and researchers have investigated several possible mechanisms. These include the inflammatory responses, oxidative stress, vascular changes, possible effects on the cochlear or auditory nerves, stress, and sleep disruption. What interested me was that my experience didn't feel like one dramatic event suddenly damaged my ears. It felt as though my whole system had been through an inflammatory illness. I healed, but something afterward wasn't functioning normally. Again, that's my personal observation. It isn't proof, but sometimes observations raise questions that science later helps to explore. That's exactly what happened with my Instagram experiment. Here's another piece of research that supports the importance of sensory input. Scientists are deliberately combining auditory stimulation with somatosensory stimulation to try and change the tinnitus-related brain circuits. This approach is called bimodal neuromodulation. In one large randomized study involving more than 300 adults with chronic tinnitus, researchers paired sounds delivered to the ears with electrical stimulation delivered to the tongue. Participants experienced reductions in tinnitus symptom severity, with some improvements continuing after treatment. A later clinical trial also found benefits from pairing auditory stimulation with tongue stimulation in people with moderate or more severe tinnitus. Why would stimulating the tongue affect a sound that appears to be coming from the ears? Because the auditory somatosensory systems interact. Scientists are using one sensory system to influence another. There is even ongoing research examining sound combined with vibrotactile stimulation, where vibration provides additional sensory input through the body. When I was dealing with my own tinnitus, I used a handheld massager over my shoulders, neck, and back of my head and gently around the tissues near my ears to relax the tissues and improve lymph flow. That's my personal experience, not a proven tinnitus treatment. But knowing what we know about somatosensory tinnitus, it raises an interesting question about how touch, pressure, movement, and vibration can influence the sensory information reaching the brain. We don't yet know exactly how effective those approaches will become. It did help me, but conceptually, this brings us back to the beginning of the episode. Touch and movement can influence what we hear. Tension in the jaw and neck can change sensory input, while stress and poor sleep can make the nervous system more reactive. And ultimately, the brain plays a major role in how tinnitus is processed and perceived. Tinnitus is much more than a sound being created inside one little structure of your ear. Which brings us to the most practical part of today's episode. After hearing all this research, you're probably wondering, what can I actually do? The first thing to understand is that there isn't one type of tinnitus with one cause, so there isn't one approach that works for everyone. If hearing loss is part of the problem, hearing aids can help restore some of that external auditory information reaching the brain. Sound therapy can also reduce the contrast between tinnitus and the sounds around you, making the tinnitus less dominant. And as we discussed earlier, CBT can help change the brain's reaction to tinnitus. But based on what we've learned about somatosensory tinnitus, there's something else I want you to pay attention to. Does your tinnitus change when you turn your head? What happens when you clench and relax your jaw? Does changing your posture affect it? Does touching or applying gentle pressure to certain areas of your face or head change the loudness or pitch? If it does, that's useful information. It doesn't automatically mean you have somatosensory tinnitus, but it's worth discussing with an appropriately trained healthcare professional. And remember the research we discussed earlier. In selected people with tinnitus and cervical problems, addressing neck dysfunction with physical therapy has improved tinnitus complaints. So there are also a few gentle things you can try at home to help relax the muscles of your neck and shoulders. We want to start with the chin tuck. Stand or sit comfortably and gently draw your head straight backward. It's very gentle. You're not putting a lot of pressure, almost as though you're making a double chin. Don't force your head downward. You're simply bringing your head back over your shoulders. Hold it for a few seconds, relax, and repeat. It's a very gentle movement. This is, again, working with the muscles and tissues in the back of the head and neck. Now, try a gentle neck stretch. Slowly bring one ear toward the same side shoulder until you feel a comfortable stretch along the opposite side of your neck. Don't pull on your head or force the stretch. Hold it briefly, return to the center, and then repeat on the other side. Do it, 5 to 10 times to start. You might be surprised by how much tension you're carrying through your trapezius muscles, shoulders, and the base of your neck. And this is where I would add the LymphMan shoulder shuffle. This is powerful. This improves whole body circulation and lymph flow by releasing tissue tension in the neck and the shoulders by the subclavian vein, where all the lymph in your body has to flow. Instead of holding a stretch, we're creating a gentle alternating movement through the shoulders, trapezius muscles, and clavicular region and neck. Again, the clavicles are the bones in front of your neck. Stand comfortably and relax your arms. Move one shoulder upwards while the other moves down, and then alternate from side to side. One shoulder up, one shoulder down. Don't force it. If you have pain, any type of surgery in your neck, check with your physician. But you can start also slowly. Just do it. Hardly move your shoulders a few times and see how it works and see how you feel the next day. Don't force it. Let the movement become easy and rhythmic. And once you are comfortable with it and you don't have pain, really Do it quickly, about 20 or 30 times, a nice alternative motion. Oh, and you can just feel your whole body opening up. I have tingles throughout my arms and my legs. Do it about 20 or 30 repetitions, 2 or 3 times a day. If you have pain or had surgeries in your neck and shoulders, start off very gently and start off once a day to see how it feels the next day. The shoulder shuffle is not a proven treatment for tinnitus. You can also drain along the sides of your neck to support lymph flow. Put your index finger right under your ear. Your fingers, lock them in place. We're not going to slide. We're going to stretch the tissues down and release. We're pulling right into the neck, the jaw, and the ear, even into the cranium. Just stretch and let it go. So your finger is right under your ear. I'm going to stretch down and then release and go to the same place. And do this 10 to 20 times, nice and gentle. We're pulling cerebrospinal fluid and waste into the lymphatic system, which will eventually come down to the subclavian vein. But think about everything we've learned in this episode. Muscle tension can change sensory input coming from the neck and shoulders. Movement supports circulation. Muscle movement helps support lymphatic flow. And reducing physical tension can help the nervous system move away from that constant state of guarding and alertness. So rather than thinking, I'm doing this exercise to make my tinnitus disappear, think, I'm helping create better conditions for my neck, nervous system, circulation, and lymphatic system to function normally. And while you're doing these movements, pay attention to your breathing. Try taking 10 relaxed deep breaths, allowing your diaphragm and abdomen to expand as you inhale. Then completely exhale using extra force at the end of the breath. Deep breathing can help calm nervous system arousal, and the movement of the diaphragm also helps support the normal movement of the lymph through the body. So what we do is just take a deep breath in, sit with good posture first. Posture is always key for the lymph system, head back, shoulders back, and just take a deep breath in through your nose or your mouth and blow it out. Take a deep breath in and blow it out. Just doing those few things, the LymphMan shoulder shuffle, the draining of the cervical lymph vessels in the neck, and taking a few deep breaths, I have tingles along the top of my head and behind my ears. Deep breathing can help calm nervous system arousal, and the movement of the diaphragm also helps support the normal movement of lymph. And there's something important I want you to do with all of these exercises. Don't keep checking for tinnitus every 30 seconds. If you constantly ask yourself, is it quieter? Is it louder? Is it still there? You're teaching your brain to keep paying attention to the sound. Do the movements, relax, breathe, and go on with your day. And don't forget sleep. As we've already learned, poor sleep can make tinnitus more intrusive while also affecting brain fluid clearance processes. If tinnitus is interfering with your sleep, that's something worth addressing rather than treating it as a separate problem. Finally, people ask me, what about supplements? Magnesium, zinc, vitamin B12, vitamin D, and various antioxidants have all been studied in relation to tinnitus or hearing health, but the evidence doesn't support the idea that one supplement universally treats tinnitus. I would approach this differently. Instead of asking which supplement treats tinnitus, ask whether your body is deficient in something that your auditory system and nervous system need to function normally. If you're deficient in vitamin B12, vitamin D, zinc, magnesium, iron, or another important nutrient, identifying and appropriately correcting that deficiency can support normal physiology. That's very different from taking large amounts of a supplement simply because it's being marketed for tinnitus. So rather than asking, what's the best supplement for tinnitus, I want you to step back and look at the bigger picture. Are you getting enough restorative sleep and protecting your ears from damaging noise? Are you giving your body the nutrients your nerves, mitochondria, and inner ear need to function? Are you moving every day, or are you spending hours in one position with tension building through your jaw, neck, and shoulders? How much chronic stress is keeping your nervous system in a heightened state? These are things you can actually begin working on. Improve your sleep, protect your hearing, move your body, exercise, relax your jaw, neck, and shoulders. With the LymphMan shoulder shuffle, it works. Use the gentle exercises we just discussed to reduce tension and support movement and lymph flow. We also have to discuss diet. When it comes to diet, there isn't one proven tinnitus diet. I would focus on eating in a way that supports the health of your inner ear, blood vessels, mitochondria, and nervous system. That means plenty of whole foods, vegetables and fruits, especially berries and leafy greens, healthy fats from food like olive oil, avocado oil, nuts, seeds, and fatty fish like salmon, adequate protein. These foods provide antioxidants, vitamins, minerals, omega-3 fats, and other nutrients your cells need to produce energy and protect themselves from oxidative stress. At the same time, reduce the foods that can work against that healthier cellular environment, especially highly processed foods like white flour, white rice, excessive added sugar, and diets dominated by refined carbohydrates and unhealthy fats. And pay attention to your own triggers. Some people report that alcohol, caffeine, or high sodium meals can make their tinnitus more noticeable, and that isn't true for everyone. I wouldn't automatically eliminate those foods unless you notice a consistent relationship. The goal isn't to eat a diet that magically stops tinnitus. It's to give the cells of your inner ear, brain, blood vessels, and nervous system the nutrients they need to function as well as possible. None of these things guarantees that tinnitus will disappear, but they support many of the systems we've learned that can influence the health of your ears, brain, and nervous system. Before we finish, there's one more thing I want everyone to understand. Not all tinnitus should be approached with exercises, supplements, relaxation, or lymphatic work. If you suddenly lose hearing in one or both ears, especially if tinnitus appears at the same time, don't wait to see if it goes away. Sudden sensory neural hearing loss is considered a medical emergency because treatment is more likely to help when it's started quickly. Contact an ENT or seek urgent medical care. If the sound pulses with your heartbeat, that's called pulsatile tinnitus. Pulsatile tinnitus can have vascular causes and should receive proper medical assessment. Tinnitus accompanied by significant vertigo, major balance changes, facial weakness, neurological symptoms, or a significant head injury also deserves evaluation. And if tinnitus appears after starting or changing a medication, discuss it with your healthcare provider rather than stopping the medication on your own. Most tinnitus isn't an emergency, but knowing these warning signs can help you recognize when it's important to seek medical care. Let's bring this all together with 5 things I hope you remember. Tinnitus can begin with altered information from the ear, but become established through changes in the brain. The face, the jaw, the neck, and sensory nerves can influence tinnitus in some people, which helps explain why movement or touch can change the sound. Inflammation, oxidative stress, circulation, and mitochondrial health and cellular aging can affect the health of the auditory system. Stress and poor sleep can reinforce tinnitus, and emerging research is now investigating possible connections with lymphatic function. The lymphatic system is not proven to cause or cure tinnitus, but maintaining healthy lymph flow through movement, relaxed deep breathing, hydration, reducing tension in the shoulders and neck can help support fluid balance and healthier conditions for the tissues around the ears, brain, and nervous system. Think back to where we started. Why would pressing on your face change the white noise you hear inside your head? We still don't know exactly why. So many people on Instagram told me this sound changed, but the research gives us some fascinating clues. The ear doesn't work alone. Your hearing is connected with your brain, sensory nerves, face, jaw, neck, circulation, immune system, sleep, and the fluid clearance pathways we've discussed today. That's why tinnitus teaches us something much bigger about health. A symptom can appear to belong to one small part of the body, but when we look deeper, we discover an entire network working together. That doesn't mean every case of tinnitus can be reversed or that improving lymphatic flow is the answer for everyone. But instead of asking, how do I stop the ringing? Maybe we should also ask, what can I do to create healthier conditions for my ears, brain, nervous system, and the tissues surrounding and supporting them? Because health isn't created by one organ working alone. It's created by many systems working together, and maintaining a healthy lymphatic system is one important part of helping those systems function at their best. That is the lesson I hope you take away from today's episode. I'd like to continue this conversation with you. Follow me on Instagram at LymphMan, where I share new research, practical lymphatic health, and observations like the tinnitus experiment that helped inspire today's episode. And if you want to participate in the experiment I did on Instagram, I'd love to hear what you notice. Gently press 2 fingers alongside your nose and press in and then down. Notice whether the sound changes. Does it get louder, quieter, or stay the same? Does tightening or moving your neck or jaw change tinnitus? Leave me a comment or send me a message on Instagram at LymphMan and tell me what you experienced. For research references from today's episode, visit healthylymphsystem.com and go to the podcast episode hub page. You'll also find my free lymphatic health guide and 7-day plan, along with information about coaching and online courses and how to work with me. And if you have a question or would like to reach out, use the contact page there as well. This podcast is designed to help you better understand how the body and brain work together to create health, including the important role of the lymphatic system. It is intended for educational purposes only and is not intended to diagnose, treat, cure, or prevent any disease. Always consult a qualified healthcare provider regarding your personal medical concerns. If this episode helped you better understand tinnitus and how the lymphatic system helps create a healthier environment for your body and brain, please share it on social media and with someone who could benefit. Subscribe so you don't miss future episodes. Thank you for listening to the Lymph-Brain Revolution Podcast today. I'm John Ossipinsky, LymphMan, changing world health one lymphatic system at a time. Until we meet again next week, where we'll continue exploring the science behind health, healing, and the remarkable role of the lymphatic system. Keep flowing.